Anyway, I don't know. It's easy to have weird notions. Anyway, so what Braid did was, back then, it was 2007 or something when I was figuring out my final answer to how I was going to do this. And I said, hey, 60 hertz ought to be enough for anybody. It's unimaginable that games anytime soon will run faster than 60 hertz. So we're just going to design the physics to run at 60 hertz. And then on systems that cannot actually run that fast, we'll just step it multiple times, right? So at startup in Braid, we have a relatively complex test scene. It's actually one of the story screens from the game with all the clouds in it and stuff. And we actually render that off screen a large number of times and see how long that takes. We decide if we could handle 60 hertz or 30 frames per second or 20 or 15 or 12, right? And however many we can handle, we then set that as the target frame rate for the game, right? I feel like I'm missing saying something important about that. Oh, well, the goal with Braid, and again, we're going to get more into this and talk about what's really the right goal, but the goal for Braid at that time was not necessarily to simulate physics correctly. It was to have consistent results across all frame rates. And so what I was essentially doing was saying, whatever the answer is at 60 hertz is the right answer, and then we will apply that to other frame rates, right? So at 30 hertz, you just run the physics twice, and you'll get the same answer. Hopefully, if your code isn't buggy, you'll get the same answer as if you had just rendered two 60 hertz frames, right? And so that was the basic approach. Now, the problem today is that that's no longer a good idea for many reasons. So first of all, there are many faster monitors out there, even today. And so if I want to do some fixes to the game that are going to last for years in the future, they certainly have to deal with that. And it's not like they're all 120 hertz or something. There are 120 hertz monitors. There are 144 hertz monitors. I just ordered a 165 hertz monitors. These are all weird numbers that you know, you can't really design for a frame time that you know is going to fit evenly into all these frame rates, right? So it's not like you can just do multiple steps like I did in the 60 hertz case. You know, even if I tried, I mean, even if I said I don't want Braid to run any faster than it already does, I just want to run at 60 hertz, that's going to produce bad results on some of these monitors. So if I try to do that on a 144 hertz monitor, if I'm not going to change the display refresh rate, you know, 60 doesn't divide 144, right? So you're going to stutter. Some frames are going to be longer than others. Unless I change the resolution and refresh rate, but that has never worked very well on Windows, and games are generally getting away from doing that because it's such a support nightmare. It's pretty terrible that Microsoft has never actually made this work, but whatever, they don't really care about games, regardless of how much they'll say they will. What they really care about is the Microsoft Store or games for Windows Live or whatever is the current implementation of that. They don't really care about making games work well. That's obvious. And people at Microsoft will tell you that's not true, but it's obviously true based on the history of like what has actually happened. There are small numbers of people at Microsoft who care. Like the DirectX people usually actually care, often actually care. Anyway, so you know, I don't want to change people's monitor refresh rate anymore because that doesn't really work, and it generates bad experiences for people anyway. So you want to be able to render at the monitor refresh rate, or if someone has a G-Sync monitor, then the refresh rate's up to the game, right? So then it's a whole different question, but related, of what should the frame rate be? Obviously, maybe as fast as you can go, but actually not really. And maybe this has to be two different talks because it'll be too much. Maybe we'll do the G-Sync stuff next time. because I'm still figuring that out as well. As far as I know, nobody really knows a good answer for how fast should a G-Sync game render. Let me actually illustrate that. This will be a last bit of context. Can I elaborate on changing screen modes and going full screen and why it is a problem? It's a problem for many reasons. First of all, because it just doesn't work in Windows. Like, how many games have you ever run that have problems going full screen or have problems going back from full screen? Right now, Braid, as shipped and as has successfully run on Windows for years, now crashes on Windows 10 if you Alt-Enter and then Alt-Enter again to go back into Windows mode. Why? I don't know. It's just this stuff is a nightmare in Windows, and nobody knows the right answer to what the code should say, including people at Microsoft, right? So you're just randomly guessing at how to handle going into full screen modes, right? So first of all, from a code reliability standpoint, it's bad. Second, from a user experience standpoint, it's terrible, right? You're changing resolution so people's monitor goes black and maybe doesn't come back. Maybe it just stays out for a couple seconds and then comes back. Maybe when people quit the game, their Windows desktop resolution is different and icons have all moved. That's not supposed to happen anymore, but it totally still does, even using DirectX 11. I've seen it happen. People's monitors do not necessarily do the right thing. So if you pick a display mode that you can render effectively, like say 1080p, right? 1920 by 1080, that's a 16 by 9 aspect ratio. On a 16 by 10 monitor, very often they'll be configured to stretch the display by default. So now your whole game is stretched, and you have no way of seeing that that's happening, and you have no way of telling the monitor, no, don't stretch. You know, display as aspect, right? There's supposedly, I guess, some display modes in DirectX that maybe do that, but they don't really work as far as I've ever seen, not consistently, right? So there's no, basically it just doesn't work, and it doesn't work in a way that is totally out of the game's control on every axis, right? So if instead you just render at the monitor resolution, and you know, if you can't render at the monitor resolution at full frame rate, like say it's a 4K or 5K monitor and you've got a very graphically intensive scene, you render to an off-screen buffer and then you upscale that, right? And then maybe you draw the UI at the full resolution. And that will give you the best combination of reliability and good user experience on all operating system configurations. It's what most games are doing these days. Yeah, Sean's even saying Rocket League crashes 10% of the time when he alt-tabs to desktop. And that's a very popular game where there's a large financial incentive to maintain it, right? And they are maintaining, they're releasing expansion packs all the time and stuff. It's just a disaster. Like, this stuff has never worked in Windows. And because Microsoft's gone the route of making Windows more complicated rather than more simple, technically, it's never going to get fixed, right? We're past the point. You know, 5 years ago, I might have hoped that with the next major Windows revision, this stuff would get cleaned up, because they've done that in the past. Like Windows NT was a whole endeavor of, hey, we're going to make good technical foundations for Windows and we're going to switch to them. But that didn't seem to be the primary motivation for very long. Like, things very quickly got garbagey again, and now I think with Windows 8, they're past the point of no return. Like, they've now made their one OS into two OSs, and they have to maintain all that complexity forever. And they weren't even well maintaining the Windows 7 complexity, right? So it's a disaster, and I don't think it's ever going to get fixed. But in the meantime, until something else replaces Windows, which is not looking likely anytime soon, you know, most of the people who play the games that I make on PCs are going to play them on Windows. So we got to deal with this. We got to do our best to make games that are robust on these platforms. And that is why I have to think very, very hard about how to frickin' display full screen at the right frame rate when it should be almost something that the OS does for you, right? On the PlayStation 4, you don't really worry about that, for example. It just works. Okay, so that rant rant one of many is now down. Um, what's in my head to talk about right now is the G-Sync stuff, but I'm not going to do that yet because it'll make the discussion too sprawling. So let's start talking about actual frame rate independence, and then we'll go from there. Now, in Sean's talk yesterday, I'm going to do some graphs that were a little bit differently from his, but he was basically talking about how to simulate physical objects, and I'm going to recap that because it's an important idea, right? So I'm just going to have a situation where, let's just say I've got a couple of objects. They're going to be like 2 balls or something, and they're moving at some velocity. So this is space, right? This is the x-axis, and that's a terrible y. This is the y-axis, right? I wish I could easily have separate colors. Why doesn't this program just have little? Anyway, so this one's going this way and this one's going that way. So they're going to collide at some particular point in time, right? Time is not an axis on here, but you can just imagine these things moving along these arrows, right? And then say I've got a third one, right? I've got one over here, and it's going like this, and it'll eventually intersect with this guy, right? So how do you resolve, how do you figure out what's going to happen? Well, if your frame time is such that each frame is just a tiny, let's say it's 10 or 11 frames before these little barely visible things are supposed to represent how far we are each frame. If each frame, this guy just creeps along, creeps along, creeps along, creeps along, you don't really have any problem because your time resolution is very high relative to the events that are happening, right? So what'll happen is these 2 balls will hit each other right around there, right? And this one will like scatter that way, and this one will scatter that way, and then either this ball, and let's label these A, B, and C, right? Either B and C will miss each other, right? So B is going to come this way. Either B and C will miss each other because C already went first, or they'll hit, but they'll hit, let's say they hit, right? They'll hit back here instead of here, right? And that'll have a big, that'll have a very big difference in the final position and direction of C, right? Because if C were hit here, then C would end up that way. But if C were hit here, C would end up that way, right? So what happens to C here depends very much on whether A and B hit each other, right? So like I said, if your frame rate is very high, or if your physics simulation rate is very high, there's not going to be any ambiguity here. But imagine that the time between frames is so much that, I don't know, let's say you get this much distance in one frame, right? So all of these balls will have traveled past their collision points. What do? Well, what you do is this kind of, the most robust thing to do. There are a number of approaches, right? The robust thing to do is find the point at which A and B collide, or find the first 2 things that collide, right? Figure that out, resolve those, and then continue, right? So we go from T0 to T, let's call it T1/2, right? It's not going to be exactly in the middle, and then do T1/2 to T1. So we break the simulation into 2 substeps, right? And you could think of that as 2 different calls to some sim function. I want to be able to hold this like a pencil and not press the buttons. So you're basically calling sim twice or something, right? In reality, you've got a more complicated scheme that does all this resolution. And once you start trying to optimize this, it gets a lot more complicated. But the idea is you detect the first event, you react to it, and then you detect the next event, and then you react to it. It'll allow me to drag colors into a palette. No, it won't. Click on the, I'm clicking on the dot, dot, dot. It's not doing that. I tried that before. It doesn't, I don't know what you people are talking about. Okay. So far, so good. Now, this can get a little bit hairy and complicated to program, but it's not so bad if all you're doing is just physical object collisions like this. Now, the thing that starts making it hairier is, you know, in a game like Braid, you have more things happening than physical object collisions, right? And the problem is that they all have to be ordered with respect to this other stuff if you're really going to be correct. So let me start talking about that. So in Braid, for example, you've got, let's take a couple of examples. Well, first, before we talk about more complicated gameplay code, I'll just say, you know, Sean yesterday was mostly talking about ballistic motion, right? Because you can sort of assume like, oh, this body's tumbling. Say it's through this and it's going through some parabolic path in the air or something. It's not going to be exactly parabolic, but we have an initial velocity, we have an acceleration due to gravity. We'll have some friction force, which you could call f of v or something, right? So you're going to have some probably air friction pulling it backwards, even though its velocity vector is forwards, right? Etc. So, you know, you usually do something, I'm probably going to biff this badly, right? But you usually do something like x sub 1 is x naught plus v naught t plus 1/2 g t squared, right? And then, well, do you try to work this friction component into the position you need to if you're going to be frame rate independent, but whatever. Let's not care enough about that yet. You'll say, because I'm just trying to disambiguate the concepts. So you'll say like, you know, V1 equals V naught plus GT plus well, it depends on, I'm thinking now about what units does my f of v, my monitor brightness here is auto-adjusting. It's driving me nuts. Computers are terrible. You people who think the singularity is going to happen are off your rocker. Oh my God, I can't even get this screen to display at a consistent brightness. And you guys are worried about robots killing everybody. Okay. While I'm being bothered by this, let me erase all this stuff. What is it? So if my f represents an acceleration, then it's just like g. So let's say that f is an additional acceleration, and it's an acceleration that's proportional to the velocity or something. Then if you're discretely evaluating it, you might do something sloppy like f of v naught t, right, or something. The problem is that you really want, this is really a differential equation, because the parameter to f is the velocity, and the velocity is changing during the time step. So like really, you the simplicity with which you can evaluate this in closed form depends greatly on the form of f, right? If f is something simple for which you can evaluate the different, or for which you can write the differential equation in closed form, you're fine. Otherwise, you need to like get a solver and stuff. Anyway, this is a little bit outside. I don't even remember what that function is for Braid. Anyway. The interesting thing to say about this, though, is all of this could be closed form with appropriate appropriately. Appropriately. That's actually the thing that's way better about the iPad, is it doesn't have stupid buttons on the pen that I accidentally hit. Could be closed form with appropriately chosen equations. But the thing about so-called appropriately chosen equations is that that then constrains you over what the motion in your game could be like, because maybe you don't like a particular kind of motion and you would like it to work a different way. If you have any if statements in your logic, for example, for this friction, then you're out of luck, right? That's not going to be closed form at all. Yeah, anyway. So that's the basic form of what you do when there are physical objects flying around. Now, in addition to physical objects flying around, I should just make this bigger. There's other stuff that happens, or at least in addition to ballistic motion. So let's start with non-ballistic motion, first of all. So in Braid, you have like characters and monsters, right? And let's not make the character green. So I've got a character. He's very happy. That didn't come out well. And he's on the ground, and the ground is green. And it's in Braid, the graphics tend to look very smooth often, like smooth curves and stuff, but it's actually a piecewise, the collision is a piecewise linear approximation. So this guy is essentially standing on a bunch of line segments. Like if there's a hill, it's like this. And then the idea is that the curvature of the hill the curvature of the hill is subdivided enough that you don't notice the fact that it's a linear approximation, right? That's the whole deal. Anyway, the reason I've done things in different colors down here is that, so this green area, I'm now drawing in a totally different color, but this green area is sort of one chain of surfaces, right? And this is like a moving platform or something, and this is another chain of surfaces. Now, when this guy walks, right, he's not moving ballistically, right? He has some special case surface following plus like walk acceleration, right? So what happens is, the player has acceleration, deceleration built into him, but then also he's following along the surface. So he goes a certain amount this way. And then when, he's got some support point down here that decides at all times, which surface he's on. And at some point, this support point will transition from one line segment to another. And that changes the direction of the character through space, right? So he moves just fine in a linear fashion until he hits one of these. And then he moves in a linear fashion here until he hits one of these, and then etc. Now, it's not totally dumb, straightforward motion, because there could be a brick wall here or something that he also has to collide with. So all the gameplay logic has to happen. But this is an example of non-ballistic motion, right? So if you shot a cannon, let me get rid of this. This is in a totally different space here. So now we're just talking about a game level. So let's make it clear that we're talking about a game level. We've got the sun up in the sky, and it is radiating, right? And then, so let's say we've got a cannon, right, here, and it's on a platform, right? And this cannon has a little cannon fuse, and it shoots. In the game, they're little monsters, but just think about a little ballistic cannonball or something. Wow, my camera is like really zoomed really close or something. You can't see me most of the time. Let me back it up. I don't know what's going on. I know the camera has a built-in zoom that's like, I don't know what's happening there. Anyway. So this is, yeah, now I'm hitting stuff on my tablet that I don't want to hit. Okay. So, in fact, people on my art team do this with their Wacom tablets all the time, that I've seen, just hit buttons and, yeah. Bad design, but they're somehow the market leader still. Okay, so, you know, say this guy shot something out, and it starts with a linear velocity. I don't want to update virus protection. Shut up, shut up. I'm giving a presentation. So, you know, you shoot something out of there, and it starts, you know, it starts here with some velocity, but you know, it's gonna move in a parabola due to gravity, and then maybe it'll bounce here, right, off the top of this wall. So we're gonna have some arc. Boink. Right, so this is ballistic motion, but this is a different kind of motion, right? The character, like some games might try to do character. Wow, I'm having trouble. Let me just pop up OBS for a second. Like the latency in the Twitch stream makes it hard to, okay, it's almost right. So, you know, naively you might think, well, in physics, you're just falling through space all the time, so I'm going to do player motion by having him fall ballistically and then hitting the ground every frame, and the ground's going to push him up. Well, that kind of sucks, actually. So really on the player, there's a flag that tells him whether he's in ballistic motion or standing on a surface, right? Because if you walk off the end of a platform, you want to fall naturally, but when you hit the ground, you don't want to be falling every frame and being held up by the ground. You want to actually have a smooth motion that's governed by some other gameplay logic, right? Okay, so this is all just to say, this has all just been an intro to the fact that if you remember our physics example, I'm gonna put this is a cloud into another universe here where we had our physics example with the two guys colliding, right? In addition to solving stuff like that, which we call physics, we have to solve stuff like this, which is, let's start by saying alternate physics, right? It still has to do with physics. It's still how the player is moving through the world, but it's not anything that you would recognize as physical simulation, right? It's more just like some ad hoc code that makes the player move smoothly around the map, right? And all games have this. It's how games feel good, right? Except maybe Trespasser didn't have this. I don't know. Okay. So in addition to when you're going to sort the scene and say, find the first event and determine what's going to happen, then in addition to considering things like this when you're talking about finding the first event, you have to consider things like this. Because this guy is going to change the character of his motion, at least change the direction, when he hits that point. Now, there may be something just after that point or just before that point. Say there's a dangerous monster here, right? Is a little bit of a, it's going to be, these examples are too simple to really be very paradoxical, but you can easily get into situations where the guy will either hit this monster or not. Let's actually make it a fireball, because that'll be better, right? Let's say this is some level where there's a fireball overhead, right? Say it's being shot this way, and the player is going this way. Let me just erase some more of this. The player is following this piece of the ground, right? So he's going this way, but then at some point that's going to change and he's going to start going there, right? So does the fireball hit him in the head or not? If you extrapolate him too far during one frame upward before you notice he should be going sideways, then yes, that fireball will hit him in the head, right? But if in the middle of the frame you realize, oh, he's actually going this way, then the fireball will miss. It'll barely go over his head, right? Now, you might think, well, if you're hopefully running physics often enough, the disparity between those two cases is going to be small enough that the players won't notice it and it's not a problem. Well, that's kind of true, but you actually need much higher frame rates than you would expect. So for example, at 30 hertz in Braid, one of the reasons why I actually simulate physics twice per time step is because to be consistent with something, right? But at 30 hertz, if you were only running one physics time step for every 30th of a second, then you start seeing significant errors in handling of objects because things sometimes in the game are just moving fast enough that in 1/30th of a second they move an appreciable distance, right? And so stuff like this starts being bad. Let's erase all this actually, and let's start talking now about the general issue of frame rates messing you up. Let's leave the sun here. I like the sun. Okay, so let's just say there's a cannon now. We're resimplifying our world. You got a cannon. It's on something, right? And it's going to shoot stuff. Should have done that in a different color. Can I Control Z on my Bluetooth keyboard? Yes. All right. So this cannon, I just want to make more of a scene here. This cannon is shooting projectiles. Right? And they're going to arc because that's what gravity does to things. Boom. Pretend we're playing like whatever those cannonball games are, right, where you shoot things. Now, if you are being very serious about evaluating the path of this projectile, you know what? To make the case even easier to understand, we're gonna tilt our cannon upward even more. All right, so the cannon's, because I want a bigger arc. All right, so he's firing projectiles. You know, in these games, sometimes you want to like shoot over a wall. So this is going this way, right? It's going to arc, oh, boom, right, and hit here. And we do have a wall here. And let's say the wall is just short enough that the cannonball should be able to fit over it at this angle. This is a very gimpy wall, sorry. Wall. Okay, so you know, the cannonball, I'm going to just draw it dotted here, should just fit over. Now, if you somehow evaluate your physics perfectly, then you get the right answer, right? The cannonball will fit over the wall, right? But say you don't. Let's say you sample at some frame rate, whether it's 30 hertz or 60 hertz or whatever, 240 hertz, just you're going to sample at some frame rate and you're going to get some sample points. So the cannon fires, that's one time, right? And then the ball goes, actually, the cannon fired some time ago. So the case that I want to illustrate is when the frame rate isn't quite high enough, or the physics update rate isn't quite high enough, right? So your ball is here, and then it's here, and then it's here, and then it's here. Let's say those are the samples, right? Now, if you pretend motion is linear between all these samples, or you don't evaluate it perfectly. Pretending it's linear is one of the lowest grade things that you could do. But let's just do that to illustrate the problem, right? So you could be treating it as though it went along this set of segments, right? Because you're sampling the position at these times and then asking if things collide. In this case, your ball is going to hit the wall right here, when really it should have gone over, right? Now, maybe it doesn't matter, right? If your frame rate is high enough, then this could still be kind of wrong, but the error could be low enough that nobody will notice. That's fine if you're consistent, but let's say this is 30 hertz, right? Let's say orange is 30 hertz, and then 60 hertz would be double that, right? So let me pick a different color, like cyanish, aqua color. So I'm just gonna, these aren't really evenly spaced, but I'm just gonna put, so 60 hertz lands exactly on 30, so I'm gonna put one of these on every 30 and then one halfway between, right? So here, halfway between, here, halfway between, here, halfway between, here, right? So now if you, even with this bad linear approximation, if you draw what happens, you're much closer to the curve. And here I got lucky and I got right over the wall, right? Whereas 30 hertz didn't get lucky. You get the idea, right? So both of these are piecewise linear approximations that are inside the parabola. But one of them makes it over the wall probably, or maybe it hits here. The point is the result is different, right? And now if your frame rate is changing every frame, which happens on some PC games, we can talk later. There's lots of reasons why that's bad. But if it's changing every frame and you lock your physics frame rate to it, you'll get totally unpredictable results in cases like this. Wow, I've been talking a long time and haven't even gotten to really anything Braid specific. Let me just say, are there any questions so far? I'm going to leave for 1 minute and get water. Put some questions in the chat, and we can address anything so far, and then we can move on. I am looking for questions. Someone says it seems slightly different than how an engine like Unity would handle collisions. Seems like here you're trying to do some prediction or calculation about what path an object took. No. So someone is saying putting the object at every point and evaluating overlap. That doesn't work. Like, everybody knows that doesn't work, because then you have tunneling, right? So if you have a fast bullet, right, bullets are red. So I've got a bullet here and here and here and here, right? It's moving linearly through space, and I've got a wall. You know, you're going to tunnel through the wall. Like, every amateur frickin' game programmer knows that that happens, right? So you can't just evaluate the object at every frame. you have to do some kind of between frame handling, right? Ah, tunneling, right? So a very cheesy thing to do, but that often is good enough for some cases, is you just also test the line segment between each of these, right? And then you notice, oh, the line segment intersects, right? Now, actually, though, I mean, that's good enough for some cheap purposes, but actually it often produces undesirable results. And so really what you want to do is you want to do a, for example, let's say this is a bullet, and I'm saying that the body of the bullet is a sphere or has a bounding sphere or something. I'm approximating it by a sphere. You can do a, you know, a swept sphere versus this would be a rectangular solid test, right? So you would say, let's say P is the position of the sphere, right? And it's going through space. This is one case where you start saying, how do I approximate the motion? Because to do a swept sphere test, right, you would say, well, P of t is P naught plus VT, possibly, I want to put plus question mark, right, some other function of gravity and friction and whatever, and time. That could be arbitrarily complicated. Now, the thing is, if you assume that this is linear, right, let's say this is P0 and P0 plus VT, then this is essentially if linear motion it's a cylinder with rounded caps, and it's not that hard to do that collision problem, right? But it's by no means ever as complicated, as simple as just evaluating at different endpoints. I mean, if your Unity game does that, it's, I mean, I'm not surprised because Unity games are often not very robust, but whatever, right? So, now I just said, though, in the previous diagram that linear motion is bad and often to be avoided. And like I said, you can start making this more complex, and you make the equation, maybe the equation is no longer evaluable in closed form. Maybe it is, but either way, maybe it becomes harder to do the collision problem itself because, you know, this equation being in closed form or not is probably is definitely related to whether this is an easy collision problem or not, but it's not the same statement as far as I know. Maybe it's sort of it. I need to meditate on that for a while. Okay, let me go to some other question. Other questions. Isn't it almost always best for puzzle games in which predictability is very important to have fixed frame rates? Well, yes, it is, but maybe I'll get to that issue later. I mean, that was the choice that I made back in 2007, was that Braid would run at 60 hertz, and that would be the definitive thing, right? But if someone has a 144 hertz monitor, so first of all, why should you limit yourself to 60 hertz? But second of all, you can't even render properly at 144 hertz if you insist on running at 60 hertz. It doesn't make sense, right? I mean, you'd stutter. So you can't do that. I'm going to skip the question about what's the math for a real cannon shooting simulator. The cannon example is not that complicated, actually. If that was all you had to deal with, then you'd be home free because, you know, for a cannon shooting an iron cannonball, friction is not that big of a component, and you're mostly just doing ballistic motion, and you're fine. Let me okay. Let me see if there's other questions. Oh, there are. That's something. Okay, I just read a question that I'm going to come to eventually anyway, so I'm going to skip it. I don't know. People are saying stuff to me that isn't questions, and it's very confusing. Okay. Now, I talked about, you know, so first we had, remember, we had our guys colliding, whatever. We had our ballistic motion. We had our non-ballistic motion. Ugh. Eraser. Let's call it ad hoc motion. These are different things, so I'm going to put them in boxes. But there's a third thing that is not even motion, right? It's gameplay-driven state changes. That's a very general word, but this is a very general situation, right? So for example, we've got a cannon, right? And it fires a monster. And at some point at t sub 7, new monster appears, right? That's not any kind of physical extrapolation of things that happened before, right? It's a new thing, right? Or another example of this is, you know, something like we've got a key. We've got a key being held by someone, and there's a gate that's locked, right? And just to make it crazy, we're going to put something on the gate. We're going to put a monster on the gate. I didn't end up doing this anytime in Braid, I don't think, but some mods did it, right? So, you know, at T9, or T whatever, key impacts gate, gate opens, monster starts going down, right? The physics engine can't predict that the monster starts going down because that's sort of determined by what some gameplay code on the gate is doing, right? So all this is just to say that this kind of a thing not green. Oh yeah, purple, purple. This is all gameplay code right? And this stuff over here was Well, this is engine code mostly. These two are the ad hoc motion and the gameplay driven state changes are gameplay code. All right. There is lots and lots of gameplay code. It is the most messy code in the game, almost by definition, because it's not a system so much. It can't be systematized the way that an engine can be. It needs to be cheap to modify and build, right? So all of this so far has just been to say that if you're going to try to take this right answer for ballistic motion that's known, and is not too complicated, it actually gets complicated as you try to optimize it and all that in this ballistic motion case. Once you start trying to apply it to a whole engine, including gameplay code, stuff gets crazy, right? So now here is why stuff gets crazy. And this is, again, going to take a little bit of time to get. Oh, come on. I want to miss out on the browser. Thank you. God, Microsoft is killing me. Okay. As Sean mentioned, I guess it was even yesterday. I don't know when it was. Your typical loop for a game looks something like this, right? You read input, you simulate, and you render. Now, if you're Bungie and you think it's a good idea to add frames of latency in order to get throughput, then you might do something more complicated here, having to do with multi-threading and stuff. But this is the most basic case, right? And then after that, you loop around to there. So every frame, you're doing these three things, right? And you do them in this order, right? You want to read input before you simulate because you want, when you simulate the player character, that player to respond to the most recent events, for example. Now, what does simulate mean? Simulate has stuff like, do ballistic motion in it, right? And in Braid, this is actually more complicated because we have to simulate things going forward in time and backward in time and whatever. That's a semicolon. Let me fix my janky semicolons. Okay, but before you do ballistic motion, you want to call the entity's update function, right? I'm just going to call it update for now, but it's the thing that has the entity respond to changes in the world. So in principle, you say for all entities update, right? And what does that mean? Well, for example, let's say we have a cannon. What just, was that some multi-touch crap? What just happened? Computers are terrible. I can't even touch the screen while I'm drawing on it. Oh my God. I have to do so much configuration to make these things useful. Okay, so why is it doing this all of a sudden? It wasn't moving before, and now it's just moving nonstop. Okay, I have to be very careful not to touch the screen. All right. Maybe if I do this, I don't want to accidentally close it. Come on, please just. All right, it appears to be locked now. So I guess if it interprets a multi-touch somehow, it goes into crazy mode. All right. So for example, let's say we have a cannon. Let me just draw in a different color because we can. Okay, what is cannon update look like? This is a sort of C++-ish pseudocode, right? Well, let's say we have some countdown timer called countdown that controls every time we shoot. Say, and let's say dt, so dt is a per frame global determining how much time has gone by in the last frame, right? So canon update says countdown minus equals dt. If countdown is less than or equal to 0, then countdown, you reset the countdown, right, equals time per shot. Like in Braid, the cannons fire on a fixed interval. So we reset that, and m equals create monster, and then m's position is something, right? And m's velocity is something. Play a shot sound. Okay, so something like that. That's the cannon probably is doing multiple things because it's got animations of its own that it's driving and whatever. And this is one of many entities, right? So a different entity will have a different update. So you know, a big one is the boss, right? The boss is a big monster that lives in a cave. And he'll have an update that says, if I'm asleep, wake if player near. Else, if time to shoot, whatever, I'm massively simplifying. Shoot, else, chase player, right? So every entity type in the game has its own one of these. And you want to run all those. Now, first of all, well, there's a lot of things to talk about here, right? So first of all, there's already, even if you're not caring about being super frame rate independent, and you just want reasonable, consistent results without doing rocket science for your game update, I've already made a couple of mistakes in the canon update here. We're just going to focus on the canon update. I just did the boss one as an example. Hopefully my reading was remotely legible. Okay, in the canon update, what are the mistakes? Because these will be instrumental in figuring out things later. Here's a mistake. Countdown equals time per shot. Oh, you know what? I didn't elaborate enough to make the other mistakes. So let's just say, let's just do the things that you would do here, like the monster's position is my position, right? Something like that. I have some place that the shots come out, and the monster's velocity is going to be, you know, whatever, shot velocity. That's just some constant that I have, right? Okay, so the reason I drew those lines is because all of them are kind of wrong, right? This line is wrong, and that line is wrong, and that line is wrong. Why? Well, because already, before you start talking about physics, this code is frame rate dependent, right? Because the time per shot is probably not, let's say it's some floating point number that doesn't exactly land on the frame boundary, right? And in Braid, that doesn't even matter, because like, even if you thought you lined it up to line on a frame boundary, like the player will come along and drop a time slowdown ring on top of it, and then there's no way it can align with the frame boundary, right? So there's no solving that. So the problem is, you know, the cannon, when the countdown is less than or equal to 0, we're resetting the countdown to time per shot, but it went negative, right? So countdown usually goes negative, which means that that it's actually shooting at an inconsistent rate. And you can actually sometimes hear this happen because the human ear is very good at picking out regularities in sounds. And I actually could hear, especially at lower frame rates, I was able to hear irregularities in the frequency at which cannons were shooting, right? Because the shot would, I was about to say because the shot would come earlier or later than in the frame. But really what's always happening is these are happening at the beginning of the frame or at the end. I mean, there's only one time in this very simplified model, there's only one time that things happen, right? It's there. Is it at the beginning of the frame? Is it at the end of the frame? That depends on what convention you adopt, essentially. Let's just say it's at the end of the frame because that's when maybe the player will see it because we have to render after all this simulate stuff. It's debatable when this time is. Okay, so countdown usually goes negative, but it goes negative by a different amount every time, right? So if dt, let's say we're running at 10 frames per second, right? Just have round numbers. So dt is 0.1 seconds. And if countdown one time is, let's say it's 0.05 seconds, right? Then we're going to subtract 0.1, and that's going to give us minus 0.05 seconds, right? And then we're going to add time per shot, which is, let's say this cannon fires every second, right? So now we reset countdown to time per shot. So countdown equals 1, right? But what happened to this minus 0.5, right? We reset the timer to 1, but we dropped this on the floor, right? This time actually passed. So we actually want to add it to here, and we want to say 0.95, right? So this really, instead of equals, this should say plus equals, right? And because it's plus equals, then this should really be while, because maybe for whatever reason, this is going to happen more than one time. Who knows, right? And then the other stuff that's wrong is down here. I mean, for a cannon, it would have to be a very fast shooty cannon, but so you probably don't need that while, but we're making it correct, right? Now this position and this velocity are wrong, again, because we're shooting these monsters out and then they're walking across the ground or whatever. But we're skipping random portions of the frame. Oh, the reason I was drawing all this over here is just to say another time, countdown might be 0.01, right? Instead of 0.05, which means it goes to minus 0.09. So you're dropping different amounts of time on the floor. This is also dropping time on the floor down here because you're creating the monster at your position, right? And you're setting its velocity. Really, you need to like sim the monster for minus countdown, right? Because the monster's been created, but if you don't let him walk forward, then you're going to see inconsistent spacing as these guys march out of the spawning point. You know, it's not even a question of hearing things at this point. Like you'll see them at different distances from each other, right? And what that might translate to is somebody in a speed run might be able to make it and jump over something at 30 hertz that they wouldn't be able to make it in time to jump over at 60 hertz, for example. Okay, now this is before we've even talked about complex equations of motion or anything, right? Now the reason I just was doing all this is just to say it's already easy to make this kind of mistake that I just highlight. Easy to make mistakes. Hard to test. Well, maybe. We'll talk about, because like, how do you know if your gameplay code is right or not? How do you know if you dropped some time on the floor or not? Probably you maybe run your game at different frame rates and see if you get the same result all the time, right? So maybe it's not hard to test, but we'll see. So here's another thing to at least be aware of, because we're not done with all the problems here. This is a problem, right? In the sense that entities update in an arbitrary order, which means that just whatever order you're visiting them in this for loop is going to determine the outcome of events in some situations. Like, let's say, like one thing that happens in Braid is that monsters will pick up a key if they run into a key and you're not carrying it, right? Well, what if two monsters hit the key at the same frame, right? They both want to pick it up. Which one will get it? Well, whoever's first in the update list, right? So that's a thing to be aware of, and maybe in some cases this update list changes order depending on what's happening, who knows. Okay, so all of that can be fixed, like this vagary about who updates first and stuff, and even all this stuff in here can all be solved by going back to this routine that Sean was talking about yesterday, which was, you know, you sim these guys, you figure out the first time of the first event, you do the response, right? And then you figure out the time of the second event and you do the response, right? So this is all happening during one frame. That's a totally illegible. Nobody can tell what that diagram is supposed to be. But in the process of doing that, now every entity's update function or tick function or whatever you want to call it has to be controlled by this scheme and has to be written around this scheme. So all update, stop it! All update procedures, they're not functions usually, must, well, if you want to do this, all your update procedures must conform to the scheme, right? And that makes them more complicated because the code that I just wrote a second ago about the cannon firing stuff was the most straightforward, like, I just want to fire stuff. Now you're not allowed to fire stuff. Now you have to do a, now you have to do something where you split your update function in two. You have to say tell me, or one of the functions would be tell me the first time, this is in canon, it's a member function, tell me the first time you would do something and what that would be, right? Because you can't just fire the monster because something might happen in the frame before you fire the monster that changes something. Maybe you would move the cannon, right? Maybe you would close a door in front of the cannon or toggle it to off, right? There's a level in Braid where there's a door that opens and closes and toggles the cannon, right? So, you know, you need this thing, which then means you need to reify all your events because you need to return something. So you need to have a bunch of code, return a time and event info And what is that event info? Well, it's something that when this simulator says it's okay for you to move now, it'll say, well, okay, here's one way to structure it, and then we'll talk about it another way. It'll call this other member function called, okay, do that thing you said of which the parameters are time and event info, right? And here you're going to switch event info.type, and it's like case shoot, then do some stuff. So we took a relatively simple update function and we've broken it into something that is really more complicated than we would like. And we've done that for all gameplay code in the entire frickin' game, right? Now another way to structure this is instead of having two methods, you could just have one where you say canon. It all depends on your preference and what you think is cleaner. Say canon maybe do earliest thing, right? Bool for real, where if for real is true, you actually do the thing, and if for real is not true, then you just return the time of the thing. That might be simpler, it might be more confusing depending on your taste. It gives you fewer procedures to mess with, but it's worth noting that still you have to return the earliest thing. So if there are 5 things the canon can do, you know, say it would shoot at 0.06 milliseconds into the frame, or what's another? Let's just say these are canons that activate and deactivate, right? It would deactivate at 0.04 milliseconds into the frame. Whatever. You have to go through your possibilities, right? And pick one and return it if you want to be correct, right? Rather than, oh, if I want to do this thing, just do it in return. If I want to do this other thing, just do it in return. Actually, that's a little bit not true because, again, in the way that I was saying that you could sweep some ambiguity under the rug in certain of these schemes, you can say the canon is going to have some ambiguity to itself over what it does. But then again, you're being frame rate dependent because if you get a scheme like this and the cutoff is between these, if the frame rate happens to make the cutoff be between these, then you'll deactivate. Otherwise, you'll shoot if you're being sloppy about it, right? So it's just to say that if you're trying to do this, really be frame rate independent, your gameplay code gets really, really, in the ideal sense of frame rate independent, where you're computing the right answer always, then your gameplay code gets very, very complicated and very hard to deal with and very expensive to write and very bug prone. Because whereas this kind of code is much more organized, when you finish writing it, it's much harder to write and it's much harder to modify. I feel like I had one more thing to say along those lines before I outline what I think I'm actually going to do. But I'm not thinking right this second of what that one more thing to say was. So let's do some more questions for a second, and then we can come back to this. Yeah, the t equals x world is a whole different case anyway. That's bananas on its own. So oh, Sean is saying, is the while maybe actually necessary to handle the t equals x feedback loop. Actually, the t equals x feedback loop is closed form, which is cool. And I just call an update function n times with a minimum granularity. It's not that important relative to the other stuff. But yeah, it turns out that if you're standing on a platform that moves as you move, then that's it's an infinite sum. It's an infinite series that actually converges. So you can compute the convergence and then just run that much. That's what I actually do. And I was totally stoked when I wrote that because I was like, yes, math works. And I know enough math to do something. I mean, it's high school level math, but how often do you use infinite sums, right, in a practical thing? I don't very often, but that was a case when I did. People are asking off-topic questions. Okay, you have 60 seconds to come up with more on-topic questions, and I'll be back. I got some Parmesan cheese crisps from Whole Foods. They're so good. All of this stuff that I'm talking about is important for almost every game. If you play a game and it feels bad, it's probably because they don't think about this stuff. Someone's asked, is the thing I'm about to outline specific to Braid, or is it something I'll be using for all future games? I don't know. I mean, at least 2 upcoming games are turn-based, and so they don't really have the same concerns. This is a thing for action games. Is having to simulate the monster a bit after being shot from the cannon the reason why they are shot in a small arc before walking in Braid? No, that's just the way the physics are and the way I liked it. Like, having to simulate it a little bit or not has nothing to do necessarily with what you see. If they would impact the ground and start walking, then they would impact the ground and start walking. Like, that part's fine. Other questions? Have I ever looked into using an action system where A and S are capitalized with time warping? I don't know what an action system is. Gameplay code data changing system. An action system does all of your data changing in sequence in a set amount of time, which updates on a frame, but can do multiple different things in parallel or in sequence. That sounds terrible. I'm sorry. I don't know why you would. Like that just sounds like the kind of system, I mean, I don't really know what you're talking about, so I can't really say maybe it's great, but it sounds like the kind of overly complicated, weird abstraction that never works out in practice. And that just binds your hands about what you can actually write code to do. Someone's saying, how would you pull data from something that happened before? From the canon, you just look at the state of another entity. Like gameplay code has entities looking at the state of other entities all the time. That's just how it works. Someone's asking, for a turn-based game with animations, would it be valuable to make the animation system frame rate independent? Yes, it would. In fact, you pretty much have to for animation to not look crappy. However, animation is generally not that hard to make frame rate independent, as long as you're not doing collision detection or something. Although, again, interpolating rotations is kind of an interesting time. Someone's saying, on frame rate independent sprite animation, suppose player character's walking animation is a cycle of 2 frames that look normal at 60 hertz. At 30 hertz, you could either skip every second frame or render both walking frames at half speed, but neither look good. Well, that's an extremely, at frame rates as high as we're talking about, that would be a terrible animation. 2 frames at 60 hertz. In reality, I never had that problem with Braid at all. You know, at least, you know, it never bugged me. If you get down to a really low frame rate, like 15 or something, then the animation is going to look a little choppy for sure, but everything looks choppy at 15 frames, so whatever. Okay. When I went and got water, I remembered what I was going to say, and now I've forgotten again. There's just so much. I imagined that this whole thing was going to be less than an hour. But there's just so much context. Like, I haven't even gotten to any kind of solution yet. Okay, the last thing to say. Remember when I had this parabola example, right? And I was taking points along it at different times, and they were causing us to do this piecewise linear thing. That is not the only frame rate dependency problem that you may have, right? Because there's and I don't want people to think that it is, because there's a different problem. Like, say by the time we've integrated friction and all our stuff, you know, we have some, whoops, I prefer to be in red. We have some arc that kind of looks like this. I don't know what it looks like. It's just a weird shape that is not really a closed form, easily expressible thing, at least not that we know how to express it, right? Then when you evaluate, so let's say, let's just call it F, right? F is that. And actually, we're gonna say that the argument to F is the previous whole state of the object, right? So let's say this is the state at time 0, well, different notation. This is going to get confusing, but let's see how it goes. So this is the state at t equals 0, right? This is the state at t equals half k, where k is some constant. And this is state at t equals k, right? Now, if we're hitting 60 hertz versus 30, that's the equivalent of either. So 30 hertz would be, first we update the object here, and then we sort of, see, this is not, this blue line that I'm drawing here is not really, is not an actual path or anything. It's just to say that we started here, and then the next frame we're here, right? So that's what we're doing at 30 hertz. And at 60 hertz, we'll be in purple. And at 60 hertz, we go there, there, there. Now, if this isn't a closed form thing, then actually, this is what we would like, actually, is that these dots land on top of each other. But they actually won't, right? What'll actually happen is something like, whoa, whoa. We get different answers. I don't know. How different they are really depends on what the equation is. Why do we get different answers? Well, because we're evaluating f in a time steppy kind of a way. So, okay, we only get the same answer if so f is going to take let's also call these, this is going to be defined as S0, S1, and S2, just to keep things simple, right? So we only get the same answer if f of S0 comma k, right? S0 simulated for k is the cyan dots, right? That takes us from here to here, right? Oh, how do I eyedropper? Can I, oh yeah, yeah. Okay, if f of S0 comma k is equal to f of S0 1/2 k comma 1/2 k, right? So we're saying if we start, and it's very simple in words, right? We're saying if we start at the beginning and step twice, it's the same as a bigger step once. Now, the problem is this is not true for almost all f. So you need a specially designed f to do this, and like I said, that function just may not be nice. It may not actually be what you want. And so, for example, if you're in the world of like physical simulation or something, then you need to solve this whole situation by numerical integration, which in essence, what numerical integration is anyway, is essentially running at a super high frame rate to get an estimate, right? You just break your interval in a calculus-like way up into really tiny things, right? Except that then there's optimizations that mean that you don't have to break it into so many tiny things. But my whole point is just that even taking that parabolic motion for granted that you can actually solve for that is not true, right? You're going to need, for most things, if you want to get the right answer, you're going to need some kind of relatively heavy duty numerical integration. And this is still not exact, right? Let's say you want an answer to 1 ULP, a unit in the last place of a floating point number. This is going to be very expensive. So you probably have to give up on, I don't know, computers are fast today, but it's probably still very expensive. So you're going to have to give up on the idea of getting an exact right answer here out of this, right? Maybe not, maybe you can do it, but it might just be expensive and or complicated, right? There are all kinds of different, there's like, different kinds of numerical integration. The simplest one is like Euler method. That's fast, but very low quality. There's stuff like RK4, which is one flavor of Runga Kutta. I don't know how you pronounce the name, but it's a relatively trying to be smarter thing. The 4 has to do with how many sample points you take and what you extrapolate from, or how many derivatives. I don't even remember. It's been a long time. The point is, this gets nutballs really fast, and you can only even do this if you don't have if statements in your code. As soon as you have if statements, then I guess you can start, you have to break it into like piecewise functions, and it becomes even more complicated. Let's just say that. Any questions about that so far? Yeah, Sean's saying his stream was 50 minutes. Mine's an hour and a half now. Someone is saying, please, 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 can we talk about the solution space and not the 10,000 reasons why simulation? Well, I think it's important to understand these things, and especially to understand why I'm going to say there's no right answer, actually. We're not even done with the part where I say all the reasons why there's no right answer, right? Here's the next reason why there's no right answer, unless you want to make your game engine heinously complicated. Keep queuing up the questions. I'll get to them in a second, okay? What is it? So let's talk about player input. Wow, my computer just got slow. How often do you read player input, right? And when do you consider it as having occurred, right? I mean, the low effort thing to do is to use Windows input events or direct input or something, and you read, you read button presses, and then in your simulate, right? Remember we were like input, right? Input, simulate, render. In this input phase is, obviously when you pay attention to player input, but that's in your frame cycle, right? So the frequency with which I'm reading player input depends on frame rate. Now, so the answer so far is I'm reading once per frame. So I'm reading my input at 30 hertz or 60 hertz or whatever. When do I consider it as having occurred? Well, usually I don't get timestamps from the operating system about when the input event occurred, right? If I'm on Windows, let's say you probably don't want to do this if you have a choice, but let's say I'm on Windows and I'm using WM key events or WM button events or whatever, right? I don't believe to this day that you can get a reliable timestamp on those. So all you know is that that happened at some point during the frame, but it doesn't matter anyway, because in this simplistic scheme that most games use, basically all games use, You just say, well, that input happened at the start of the frame, and you know, we want to react with maximum speed to player inputs, right? I mean, in reality, it happened sometime in the middle of the last frame because it happened while you were rendering stuff. But you don't know when, so you're doing it now. Now, if you want to be hyper about it, you can start subsampling your frame, right? You can drop in the middle of your frame and say, what time is it? Okay, have we got any new input events? Okay, let's put timestamp. And so you can increase the resolution there. But that's already non-deterministic because it's basically impossible in current game architectures to have a little breakpoint somewhere in the middle of your code that you know is going to run halfway of the way through the frame or every 10th of the way through the frame, right? What you're going to end up doing is start a separate thread that tries to wake up and reads for input. And how does that thread exactly, you know, thread scheduling is a fun subject. And is it really going to run when you need it to run? And it's certainly not, unless it's sitting there and burning an entire CPU spinning, it's not really going to run at the time that you think it is, right? So, and even once you get that accurate enough, it's bananas complicated, and it's still not deterministic in the sense that you could run it again and get a different, get the same result, right? But what does it even mean to get the same result? Because you've got some organic person on the keyboard like hitting keys at certain times. So maybe the problem statement is when running recorded input from something like a tool-assisted speed run or something, produce the same results always. That's pretty good. Tasks can't really exist if you don't do that, right? So this is maybe a more well-defined statement than react to user input in the same way every time, because user input is never going to be the same twice. But if you have threads trying to read your input in the middle of the frame to get better input responsiveness, then you have the same problem where maybe the thread is one CPU, maybe the input came one CPU cycle early or late, right? So you're going to either read it on the first read or the second read, and then you're going to assign it a different input time based on that, right? Like, is not really going to work. And even how is your task being played back and whatever, is that deterministic and consistent? You'll go bananas trying to deal with this problem. You'll go insane. It's not really, even this, before you talk about the gameplay code, is not really solvable, right? So how often am I reading input? Well, depends on the frame rate. So the responsiveness of your game to player input is going to feel different depending on the frame rate. And that's going to control, and that's going to matter more than you think. So in a lot of games, in Braid, I don't remember how long it takes the player to accelerate. I could look this up for people who are curious and tweet it later or something, but it's not that long. I think it's probably acceleration. I would guess that it's less than 8 frames at 60 hertz, right? It might be a lot less. It might be 5. I don't know. But by which I mean if you're standing still and you press a key, then to be at full speed is 8 frames or less, right? So replying to input, so 1 frame latency. Let's say if we add 1 frame of latency to key press, corresponds to reduce acceleration by, what is it, 12%? Okay, so that's bad. So you certainly don't want that. But we've also just said it's very hard to respond to input in a predictable way anyway, right? as far as I'm concerned, my personal approach to all this stuff is just to say the right answer is just to read input as often as possible. And the best way to do that is just have your frame rate be as high as possible and as consistent as possible, right? If your frame rate varies, so if you have a variable frame rate and you're using this kind of scheme and you're handling input once per frame and you have a variable frame rate, that means inconsistent feeling acceleration. Unless you think that Braid is a special case, you know, I'm pretty sure like Super Meat Boy is like 2 frames of acceleration. It's really small to go from nothing to running, right? So Braid is actually kind of slow. You want this number to be low because otherwise your guy feels like he's ice skating. He feels unresponsive, right? Deceleration is actually much faster. So deceleration in Braid is very fast because you want to be able to stop when you want to stop, but it's not instant. So again, all this happens. This has not been a very coherent, this whole talk has not been very coherent because it's basically completely unprepped. It's just me getting through all these thoughts about this stuff. But basically, I don't know a way to deal with player input correctly, is all I'm trying to say here. I don't know a good way to do it, except have your frame rate just be really, really high and render fast. So let's see if more questions have piled up. Someone is saying action system handles this because you can have f of s comma k as a curve which can be sampled at whatever time step you need. That is from somebody who does not understand the problem. The whole point is you can't sample it without an infinitely large lookup table. If you have infinite memory, go for it. I know in 3D graphics, if statements can be converted into matrices that multiply by 0. I've never tried anything like that. I guess you could do that. I think it would get bananas really fast. It would get complicated and hard to deal with, but I've never done it. I don't want to hear about action system anymore. Sorry, but it doesn't sound like anything that solves anything I care about. You might like it, and that's cool, but time warping input is not something you want to do. Okay, how do I cleanly deal with an insanely high time delta after debugging through the previous frame for like a minute? Set an arbitrary max DT. Yes, that's exactly what I do. I just say DT is never greater than 1/10 of a second or something. And I leave that live. That's not just for debugging. I do that in gameplay code as well, because on a PC, you don't know if someone accidentally, you know, to this day, Windows kind of locks up a little, Windows kind of locks up a little bit if you accidentally hit the DVD drive or something, right? And that might make your game stall, and so you don't want to simulate a huge frame there. But you don't want to simulate your frame time equal to the previous frame's delay anyway. That's a whole thing that I guess we're going to get into in a different talk, but the way most PC games do that is totally broken. That's going to be in the G-Sync talk, which will be next time. Anyway, well, let me get to a couple more questions, then I'll get to the answer of what I plan to do on Braid. What did I miss? Why you don't want to generate timestamps via an explicit polling thread? Well, that's very operating system dependent and makes your code a lot more complicated and is not necessarily more reliable. Like, how do you know your polling thread goes off when you want it to, with the frequency you want it to? And, you know, like on Windows, for example, if you do need to read stuff from Windows events that's germane to controlling anything in the game, then you're screwed because you can't really process only control events in the window loop. Because you have to dispatch things out, you can't even really, you could sort of try to like skip events you don't recognize as control events and buffer them for later, and then later handle your like window iconify events and stuff in the main frame where it's safe to do that. But it gets crazy really fast. And stuff like Linux, for example, I don't think provides good equivalents of things like direct input. Of course, neither does Windows anymore, so who knows? I don't even know what's a good, I can't even tell you what the best way is to read a key press on Windows anymore for a game. I've just completely lost track. They keep changing it, and stuff breaks, and nothing works, and I don't know. If someone wants to tell me that on Twitter, I would appreciate it. Yeah, so Sean is saying, even with your Braid style fixed frame rate, something like 20 hertz is going to really hurt if you do things like jump button duration, controlling height of jump. That is true. I fortunately don't have that problem in Braid. Jumps are all the same height because it's a puzzle game, and that was important for puzzle solving. So I don't have that particular problem. So the solution I'm going to talk about solves the problems that I have. But yeah, if you expected to run at 20 hertz and you really had some timing sensitive thing like that, then you probably do need to set up an input thread. And I'm not even saying that setting up an input thread is bad, right? You might want to do it. It may well increase your input responsiveness for a corresponding cost in code complexity. All I'm saying here is just, it doesn't give you frame rate independence, really. It gives you heightened responsiveness. So if we're trying to solve the problem of being perfect about frame rate independence, it's a little bit orthogonal to that. But the reason I went and talked about input is to talk even about how the notion of full frame rate independence doesn't even make sense, which is why I am choosing to give up on it again. I gave up on it on Braid, and I'm giving up on it again for maintaining Braid. With regards to having a separate input thread, doesn't the OS and driver introduce non-determinism into the process of reading input anyway? Yes, they do. For the input, can a person notice a difference after a certain point? People can notice much bigger differences than you think, and even differences that players can't consciously notice will exhibit themselves in terms of just how hard is it to play the game, right? How frequently can people make a jump? Can they manage to jump up onto that ledge, or do they keep bouncing off it in some way? The tighter and more responsive your controls are, the more reliably people will be able to play, right? And the higher your frame rate is generally, because frame rate is a lot more than just visuals. It controls a lot of things. Maybe this is all for the G-Sync talk, though. Anyway, okay, so just to get back to what my solution is going to be, it's just going to be a modified version of what I did before, right? So what I did before is just to say, let's go back to this diagram of, we've got these guys, let's draw those in different colors. We've got these guys, and they're going, right? While buying this separate machine thing for the Wacom tablet is totally the wrong choice, because it's a very slow machine, and it's like the fan's going and it can't even keep up with me drawing. It must have like an ARM chip in it or something, or Intel Atom or something. I don't even know. Don't do that. Don't buy the Cintiq Companion, even though the tracking is way better than an iPad. Maybe I have to get the one that plugs straight into the computer. Anyway, so, okay, so then we wanted a third guy. And some stuff happens. This is all just like, look, man, some stuff happens. These guys are going to collide here, and they're going to go this way. And the idea is just to say, well, this is a mess. And who knows exactly what happens. As long as the frame rate is fast enough, then you're never going to generate something that the player will notice as being wrong. So as long as not conspicuous, high frame rate or high physics update rate means nothing conspicuously wrong, and can be made consistent with a fixed time step. For example, 1/60th of a second, which is what it was in Braid, right? To recap, in the original version of Braid, I would just always step by 1/60th of a second, and the only frame rates allowed were things that were even or integer multiples of that time step, right? So you can go 1/60th of a second, you can go 2/60ths of a second, you can go 3/60ths of a second, and so on. That's a little bit limiting. And like I said, today, that means that you can't run on certain monitors anymore. So here's what I'm going to do. My new approach is going to be a fixed time step, still, but much smaller. Where by much, I don't mean orders of magnitude or something, but I mean like 1/240th of a second, or maybe, I don't know. Like, why even pick it as a multiple of 60? There's sort of reasons to do that. I don't know. Let's, or 1/480th of a second, right? The thing about the original Braid code was it was really not very good in terms of memory locality. There's not that many live objects in Braid at once. So even if I weren't to assume that computers could go any faster than back then, I could get a factor of 5 or 10 out of optimizing that now because I know better than when I wrote the engine. And computers are faster. So to say I'm going to simulate things 8 times as much as I used to is really not that much of a problem, right? So then what I'm going to do, let's say I'm on my 165 hertz monitor, right? I don't even know. I assume that 165 hertz is not, let's assume that 1/480th of a second doesn't evenly multiply into that. I don't know if it does or not. If it does, you pick a different frame rate monitor, right? So you're going to be sampling along here at fixed time steps. So every one of these points is the same, right? So now, let me just pretend. So here's the thing is, here's our refresh, and here's our refresh. So we hit a refresh here, but we missed it here, right? We have a frame, and then about 2/5 of a frame to simulate, and we want to see that on the screen. And then there's another 3/5 that hasn't happened yet. So what do you do? Well, the thing that I'm actually going to do to start with is I'm going to optimize, right, all this. So I'm going to optimize so that I can hit that. And I'll probably just hit that anyway, running it on my modern laptop. I'll just be able to go that fast, but I'm going to optimize anyway for my own peace of mind, right? And then what I'm going to do is I'm going to run at fixed time steps. So let me label these because I didn't really draw them the same distance. But these are all the same size, right? Up until, this is still the same size. Doesn't look it, but it is. Up until this one. So I'm going to sim at the same frame rate up until that one. And then I'm going to take a tiny, tiny different time step. I'm going to go, uh-oh, red alert, 1/480 times k, where k is small, right? K is less than 1. Now, Well, at a very high frame rate, if this is 165 hertz, then we don't even have any subdivisions between frames as I've drawn here, right? Like 165 goes into 480 about 3 times. So we would have about three segments, and then a frame, and then about 3, and then a frame, you know, whatever. So in this case, actually, it would be maybe less than 3, right? No, more than 3. Sorry. Anyway, so we're going to take fixed. Wow, man, only 3 at 480. Maybe I have to make this number even higher. But so my first approach, low-hanging fruit, is just going to be to take fixed time steps most of the time. And then my non-fixed time step that I'm going to squeeze in is always going to be shorter than the fixed time step. And my hope is just that as we know, as you take smaller and smaller approximations to something that's curved, they become linearized, right? So the smaller the time step is, the better this approximation, right? So smaller time step means better approximation, which means problems kind of go away. So because we're mostly being fixed and then our variable bit is short, then I'm going to hope that just no problems arise in practice. Now, this is not frame rate independent. But I'm hoping problems go away, basically. In that this time step will be so short that you'll never see a visible inconsistency. Now that might not be true because this is only step 1 of the plan, right? So step 1 of the plan is to do this and evaluate this before we do something more complicated, right? Now step 2 of the plan, let's assume that that's not good enough, right? If it's good enough, we're done. The reason why I want to say, you know, maybe problems go away is just, again, if you have a curve and you step it really coarsely, as we saw, that's a poor approximation. But if you step it really finely, then you're staying pretty close to the curve. So the distance between the line and the curve here is much bigger than the distance between the line and the curve here. And you get that at cost of CPU and GPU and all that, but you want to spend CPU and GPU to make the game feel really good anyway. That's why people buy these really nice monitors, right? As you know from math, you know, the limit as x approaches 0 of sine of x over x equals 1 or whatever, which is just a way to say that curved things become linear. Wait, x approaches 1. Is it cosine x? I don't know, sine or cosine. Whichever one of these identities is true is the one I'm talking about. It's just a well-known thing, right? Okay. Now suppose this is not good enough. Then there's a more complicated plan that we can do. And the plan is this. And this is really frame rate independent, except, and is similar to maybe what some other people were thinking on Twitter, but with slight modifications, right? So again, we've got our thing, and we've got 1, 2, 3, 4, 5, 6, 7, 8, and you know, we said every little more than 3. That's a frame boundary, right? Which I guess means this isn't a frame boundary. Okay, so the frame rate independent version, some people were suggesting on Twitter Well, why don't you just always interpolate, right? So if you want to do this in a frame rate independent way, you can wait until this one happens, right? And then the frame that you draw is, so you've simulated this last frame, you've simulated this frame, and then the frame that you draw is, let's call this state n and state n plus 1, draw, interpolate between s of n plus 1 by k, right? So the problem with that is that this adds latency to the game, latency and variance to what you're seeing, right? You can do it. It'll make things look smooth, right? But you've added less than a frame of latency at all times. Now, in the same way that I was saying that hopefully at numbers around like 1,480, all your problems go away, maybe this latency becomes such a small problem at those high of frame rates. But who knows? You also, I mean, you're also adding weird variance to when you see your response to the input. And if you actually were to diagram out what actually happens in these cases, it gets complicated and it's not all good, right? I don't prefer to do interpolation kinds of things, but here's what I'm going to do. And someone suggested something very close to this, actually. So there's sort of, remember, there's sort of at least two things that you want to run, right? There's ballistics or just regular like physics. And think of this as just changing the positions of entities on the screen and maybe what animation they're in, right? And then the other thing that could happen is, I'll put it in a different color, major gameplay changes, player death, and whatnot. Player death is the biggest example, right, for the purposes of this. Now, the idea is that we run the ballistics and physics basically every time we need to. So we run it in fixed time steps to get consistent results, right? And then we run an extra one here, but we're going to throw that away later, right? So we're going to go here, 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 whoops, skip it, here, 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 whoops, skip it, right? So we're going to render it, or we're going to do that for the purposes of drawing, but we'll skip it for the purposes of having a fixed frame rate. So now we have an intermediate, this is an intermediate result for rendering only that gets thrown away. So only fixed time steps are real. Now the problem, if you do this naively, is that you can see really bad stuff. Like, oh, I was running and I was going to jump just in time, but we extrapolated the player into some spikes here, and you see the player die, and then you see him undie the next frame because that result got thrown out, right? To avoid that, what we do is we only do major gameplay events. We only do major gameplay events at these times, right? So we don't do an intermediate result for them at all. We only do object motion. We do collision detection to the extent that we need to detect a guy bumping into something, but we don't kill him. We don't run almost anything. Now, this requires factoring the code a little differently than it usually is, but hey, whatever. Now, again, if time step is big, intermediate results are confusing. But if the time step is small, you'll really never see the difference, right? Wow, my writing is really messy. Hopefully people can read this, right? So this is the way to get frame rate independence. You know, you basically, so some people were suggesting, well, so there are different, this might seem like a little nuanced, but the nuances are what's important here, right? So what some people suggest is, oh, in my game, I just simulate some number, however many frames fit, and then, you know, and then I just draw that, right? So here, if this comes here, then I just draw this one, right? And then when this one is here, I just draw this one. You can see I'm falling behind here, and eventually I'll get 4 sample points during a frame here. So this is bad. This is getting cluttered, but let's pick a different color. Bad. Judder, is that the term for this? I don't remember. You get judder, you get some kind of inconsistent frame rate. So this is anti-judder, but anti-judder only. It's not authoritative apart from that. And again, the hope is just that at a very high frame rate, the problems go away. And because we only do major gameplay changes at these purple points, then we don't even need to back up most of the entity state, right? So this thing that we're rendering here is going to be some non-authoritative copy of the entity state, but it'll really only contain the position and the animation frame of a thing at a particular time. So that's the plan. I'm not saying it's foolproof. And like I said, this may not even be necessary, right? This is step 2. Step 1 may be good enough. So that's kind of all I wanted to say this time. There's all this G-Sync stuff we'll get into next time. Wow, we've been 2 hours so far. Someone is saying judder is insignificant if the time step is small. I disagree. It's quite significant. And remember, it's not controlled by your physics update rate, which you can turn arbitrarily high. It's controlled by the player's display update rate, which for all you know might still be 30 hertz or less. You're not really in control of that. So I think judder looks bad. Like even just playing back skeletal animations in 3D, you can see judder in cases like that very obviously. Braid running at a high frame rate looks really nice. Oh, you know, there's one other thing I should draw on this diagram. It looks really nice and smooth, and if you introduce judder, you'll see it become jerky immediately. It's immediately noticeable. Okay, the last thing I want to say here is just that I'm going to make another set of dots of things that only happen every frame. And this is particles or other things that are cosmetics that are already frame rate independent. And those we can just sample on every display frame. And that's great because in Braid, the particles are some of the most expensive stuff, right? If you don't, so the particles in Braid are already frame rate independent. You just say the time is t, and this function gives you back the positions of all the particles. To do that, there's a pretty heavy constraint on the equations that the particles follow, but that's fine because we were able to do what we needed to do with that limited set of constraints. And in fact, we could do a lot more than we already did, right? Individual particles are generally kind of ballistic anyway, whatever. So particles don't ever exist at intermediate times. They're very quantum mechanics in that sense in Braid, where they just get instantiated for the current frame and gone. So the most expensive thing, we're not going to be doing 480 times a second or whatever. We're only going to be doing it at display frame boundaries. So there's sort of actually 3 rates of stuff happening, which is complex a little bit. It's a little bit of a complicated scheme, but it's way simpler than almost any other way that I can think of trying to be frame rate independent. Now, all this, right, and the point of this is it lets us keep our gameplay code very simple. Lets us keep simple gameplay code, which is very good. Okay. My particle system is not tweened. No, it's not. Read the articles. Someone is saying Judder is bounded by the physics update rate. Just imagine sim rate of... Oh, right, okay. Yeah, that's true. It's bounded by the Judder is bounded by the physics update rate, but has a dependency on the frame rate. Yeah. Anyway, I dislike Judder so much that I'm just not even going to go there. Are these new methods worse for slower machines than what you have in Braid right now? Yes, if only because I'm cranking up the rate really high. But on the other hand, there's so much room to optimize that I believe in the end it'll actually use less CPU anyway. Of course, I'm putting more work in, but I'm much more knowledgeable about how to make a loop like this go faster than I was back in the day. So it should be easy to make it fast. Without even trying that hard, in fact. I mean, I can get a factor of 2 out of it almost doing nothing. Like, it'll be so easy. Oh, great. I'm going to get asked action system haranguement from someone. At what point do I start talking about floating point imprecision? Floating point imprecision is more something that happens at large scales, or a mixture of large and small scales. In a platformer like Braid, you don't really have that problem so much. Anyway, water refill. Please continue to ask questions. I'll be back. Oh, the last thing that I have neglected to say is that this system, the step one of this system, which was a very don't care that much about frame rate independence, just make sure the time steps are small and step at a fixed rate, and then the last step is fractional. That has already been in the game since 2008. That's actually exactly how World 4 works in Braid, where the time step to simulate depends on your player's motion during that frame. So, I'm hearing an echo now. What happened? Anyway, I'm going crazy. So, that's how World 4 works, is exactly that scheme. And it seems okay. I don't actually know if it feels different from the rest of the game because World 4 is so weird. But I feel like if there is a difference, then it'll go away if the time step gets smaller. But we'll see. Like I said, step 2 is if it doesn't feel good or is undesirable for some other reason. Now, all this said, if I do some kind of, if I do step 1 only, I would also at least put in an option where you can force the frame rate to a certain number, and then maybe the game doesn't VSync if it can't do that on your display, right? So you could say 120 hertz, and then we just don't VSync and we run at 120 hertz as closely as we can anyway. That's a whole other topic. And then you would get a consistent feeling game that way, but you would get screen tearing, which is not great. But then the higher your frame rate is, the less visible tearing is, sort of. So, especially in 2D. In 3D, tearing is always kind of bad, but in 2D, it's not so bad. Is the witness frame rate independent already? It's not really. But we didn't worry about it so much because it's just about moving a viewpoint around. So, I mean, we did the motion code for the viewpoint to be reasonably frame rate independent, but there are things that aren't, and it's fine. You know, as long as you're aware. So, like I said, it's impossible to solve all these problems in reality. Like, so the whole system that Sean mentioned that they used in Thief, I'm sure that had a bunch of exceptions for gameplay code of the kind that I'm talking about. It probably was only for physics, because I am not aware of any game in the history of games that was fully frame rate independent, like for real, 100%. Even if you ignore input, right? Ignore the weird input stuff. I don't know of any game that ever really had its game logic be frame rate independent. It's basically so much harder than doing it the other way. There are plenty of games that have physics systems. Well, especially, I mean, if you use Havoc or something like that, it's doing the kind of thing like Sean said, I believe. Some physics engines do that, right? But then as soon as you get into gameplay code, it's a different story. Language questions, I think, are in a different talk. This is already very long. Will I be writing up an article about this system once I get it working in Braid? Probably, but it's probably going to be just what I just said. So maybe I'll just point people at the video. Well, I don't know. We'll see. Depending on how well this works, or if someone suggests something different, we might end up doing something different. Oh, is there a per object time steps in World 6? I'm trying to remember how I implemented that. So World 6 is the one where you drop this ring on the ground and things slow down or not based on how close they are to it, and then within a certain radius they're at like maximum slowness. And I believe that, yes, I do per object time steps there. So again, that's a case where well, wait. I mean, it depends on what you mean. I have per object durations, and what that just is, though, is that they run the same number of time steps as all the other objects. It's just their dt gets multiplied by some number, right? Now, Braid is weird though, because all the rewind exempt objects get their own update loop like after the main objects. I don't remember why I did it that way. There were some cases that came out better if rewind exempt things had the last say, so it's a little bit of a hack, but I don't even remember what those are. But really that's more about the gameplay logic update step than the physics step. If I profiled the update loop and found I had CPU time to do it comfortably, would you have any reservation about running the time step at 1/1000th of a second? Not really. I mean, 1/1000th of a second is not that high, honestly. Like if the game is at 60 hertz, then that's 100 divided by 6, which is 50 divided by 3, which is, 16. 16 times a frame, 17 times a frame. I mean, that's kind of high, but that's not a big number for a computer, right? 16 times a frame, eh? We do millions of triangles a frame in a 3D game. It sort of depends on your problem domain. Like Braid just doesn't have that much stuff on the screen at any time. So it's much more plausible to do things at a high update rate. Now the thing is, an issue that I haven't talked about is, so if I pick like a 1/480th of a second time step, then I am probably changing the feel of the game slightly because I'm going to have complete consistency, but it'll be consistency with a 1/480th of a second time step, which is going to have different results from the 1/60th of a second time step. So you're going to see, like, I mean, if you were to chart things very closely, like if a player leapt into the air and fell, his arc might be slightly different. How different is it? I don't know. Is it going to be different enough for players to notice meaningfully? I don't know. So I want to just try it and see. And if it's different enough, maybe slight tweaks to the constants of the world like gravity and friction might be in order, but I think they would be really small tweaks. And they're probably within the margin of error of what I would be able to tune as a game designer anyway. Hey, can someone link Sean's discussion in the chat? Someone's asking about that. Someone's saying, could I increase or decrease judder by lifting up the rewind button at some point between display frames? Not really, because rewind is a different thing. So when you're rewinding, most stuff in the game is not simulating in this whole scheme that we've talked about. Most of it is being replaced by copies of themselves from the past. Now those copies, this is an interesting topic because rewind is inherently going to have judder a little bit or something because I only store those copies at these times. And I don't really interpolate right now. For some reason, I feel differently about judder when rewinding versus not, just because it's supposed to be a weird thing that doesn't exactly represent reality or something. But the point is, when you're rewinding, what happens is, at the rate of, actually, no, there's no judder. Well, ooh, see, this is a thing. This is a thing I hadn't thought through. If I store, actually, if I do what I just said and store this one that's exactly on the line, that's the wrong thing, because then I'm making that authoritative over gameplay. So I have to store the one before it, right? Which means, well, let me Control Z that other circle so we're not incorrect. Come on. I have to store these. or something, right? So there's going to be judder when rewinding. But rewinding has lots of screen messing up special effects, and I don't mind it so much in that case. But anyway, what happens when you rewind is that at a rate of 1 frame per frame, we go backwards in time and look at the most recent state. I suppose I could store 2 versions. I could store the visual version. I could store the visual version and restore that when you're rewinding as an intermediate result so that you would have no judder. And then when you finish rewinding, I would snap you to one or the other. Yeah, I don't know. It's more complicated, but that's how things are, right? So the only things that are simulating normally are the things that are immune to rewind, right? When you finish rewinding, then we drop you back into a regular sim stream. So it's kind of a different case from all this stuff that we're talking about. Do I have a maximum slowness for what machines I want my games to run on? There is always such a thing. I ideally would like the game to be able to run on everything that Braid already can still run on, for example. For Braid, right? Witness has higher system requirements. You just kind of have to decide. I don't know. Computers are pretty fast today, especially computers that most people play games on are pretty fast. So I'm not too worried. Am I going to need 8 times the memory to store the rewind? Probably not. Because, like I said, I'm not going to need 8 times, but I am going to need more memory in proportion to the user's frame rate. Because, like I said, I'm storing 1 per frame, approximately 1 per rendered frame, not 1 per physics frame, right? So I'm skipping most of these gold dots in here. Now remember, this whole blue diagram with like 3 gold dots per blue line is for a 165 hertz monitor, right? A more pedestrian frame rate like 60 hertz would have way more gold dots that we're skipping over. So we would need more memory in proportion to the player's frame rate. And maybe we would cap it at some point, not to be insane, cap the frame rate. But I mean, on the Xbox 360 with, I forget, I had like 45 megabytes of rewind space or something on there. No, that's not right. 80 megabytes. And it lasted up to 40 minutes in the worst case. In World 4, I have to kick you out of the level if you run out of memory. And nobody ever noticed that I saw on the 360. I mean, the alternative was to just silently delete frames at the beginning of the level, but then you could find yourself stuck in the level and not get to the exit door maybe under some cases. I don't know. It just seemed better to end the level. So 80 megabytes is negligible, right? So if I have to raise that by, in fact, I think it was 50 actually. You know what? Let me go look in the file. I can tell you what it was on the PC. Variables, rewind. I don't remember what the variable's called. Oh, max memory for frame records. So 80 megabytes is what we raised it to on the PC after the Xbox 360 release. So 360 was less than that. I think it was in the neighborhood of 45 or 50 megs. So let's say someone has a 600 hertz monitor, then we need 500 to 800 megs of RAM to get the same, which is, sounds like a lot, but is trivial on any system that should have a 600 hertz monitor, right? So I don't feel like that's a problem. Oh, could I store the state and then the time step? Yes, that would actually be a simpler solution. So someone suggested, and this is a good point, instead of storing the cosmetic result here and the state before it, you can just save the state before it and then the time step, or you actually know the time step, right? Because it's just the time you want minus the time of that recording, and just simulate it forward again. And actually, now that you've said that, I'm pretty sure that Braid already does that, so we don't really have judder. I'm pretty sure we do that. Certainly we do that in places like World 4, where the time step is weird, I think. I don't know. I don't know, man. It's been so long. I'm trying to keep on-topic questions, so I'm skipping anything that doesn't have to do with technical details of this exact stuff. Have I considered scaling the time step to line up with display updates? Well, no, because that'll make the physics of the game different on different display rates, which is what we're trying to avoid. Any further questions? This has been a long stream. Thanks for hanging in for it. It's been interesting practice. I don't think I like this particular Wacom tablet. I wanted to get this so that if I do handmade compiler, that I'll have practice at drawing diagrams and stuff. And this is kind of ugly. I need to get better at drawing things that look nice. Well, if I can figure out how to set up a palette of harmonious colors beforehand, that'll help. And if I can just write nicer letters. If I take a little bit more time writing my letters, they'll come out much nicer. It's just I always feel weird about that because it's taking time during the stream, but it doesn't really take that much time. And it's much more legible. So I'm going to try to train myself. Maybe I'll just do a random Q&A during the week of about anything that people want to talk about, and I'll just train myself to write more nicely. Even my "this is nicer," the word "nicer" is kind of... Could this affect how the game looks when displaying on multiple monitors? Not really. Displaying on multiple monitors is... if you mean displaying on one monitor in a multi-mon setup, not really. It's just more a technical effort to get it right, which is again hard under Windows to do the right thing in that case. If you mean to spread the game across multiple monitors, then hopefully they're running at the same refresh rate, because if they ain't, that's going to be weird. Any other questions? Let me have some fun with my tablet. Any other questions? That is completely illegible. Yeah, I mean, we could do a topic suggestion. What kind of... Okay, we're off topic. These are not chips. They are Parmesan cheese slices. Can you see that? I have to wait until they're really good. Hopefully that was in frame. I don't know. There's so much lag on Twitch. Yeah. They're delicious. I just, today has been a day of eating way too much, really, is what's going on in my life. Eating. Why? I don't know. Ah! I do not want this. I just want it. Neither Microsoft nor Apple understands that I just want the application to own the surface and let me, the screen, the touchable screen surface, and let me do anything. Nothing I do to the screen should take me out of the app. Damn it. I realize you can disable this. I've disabled it on all my other computers, but on this one, because it's new, because I may not be using it for long, it's not disabled. Possible release date of the compiler, we don't know. We'll see. Okay, that's all the on-topic questions. And it's been a really long stream. Oh my God, I started this at 5, right? So it's like 7:45 already. Just like Sean said, you know what? There's so much, to people like us who have been doing games for decades, this doesn't seem like that complicated of a topic, but it's because we've lived through it and we've summarized all this in our heads and we just know all this stuff. But to sit down and explain it, there's just a lot to explain and it takes forever. And I didn't even get to everything that's important, actually. That was like a cursory summary of the topic, right? I didn't talk about most approaches that you could do or ways that some games approach this, or I probably forgot some things that are really important. It just, man, programming games is complicated. That was one tiny subtopic out of the many whole topics of how to do even a simple 2D game in a high quality way. So thanks for showing up. And thanks to Sean for doing that presentation yesterday, because it got me in the mindset to do one as well. I'll put this on YouTube soon if you missed any of it. And until later, goodbye, says my new tablet.